this review for the midterm. That's way too many copies, but that's okay. And as an announcement on that front, the stuff that will be covered on the midterm is the stuff that we finished as of yesterday. So today won't appear on this midterm, it'll appear on the next one. So let's talk about something new about trig functions. So we have these functions, and let's just remind ourselves what they mean. So you start at 1, 0, you rotate counterclockwise by some angle theta, you land at a point x, y. What is cosine of theta in terms of this picture? Cosine recovers the x coordinate of a point on the unit circle. How about sine of theta? How about tangent theta? Let's also remember this in terms of right triangle trigonometry. I'm going to draw this centered up here. Right, that angle theta doesn't have to be like that angle. It can be any angle in a right triangle. In terms of this triangle picture, what is the cosine of theta? Adjacent over hypotenuse. So toa. Cosine is adjacent over hypotenuse. Sine? Tangent. Cool. So we have two different meanings now for the trig functions. They tell you something about angles inside of a right triangle. They also tell you about points on the unit circle. But what's one thing we do with functions an awful lot if we want to study them? We graph the things. And neither of these are graphs of these functions. I think in order to graph them, I'm going to say, well, you have some idea what the trig function should do. So let's start with some of the things we know and do process of elimination. Provided here are two graphs. One of them is graph of sine of x, the other one is the graph of cosine of x. So, multiple choice question now. Is that the graph of sine of x or cosine of x? I hear sine. Okay, cool. Well, since this is like a multiple choice and there are only two options, let's process of elimination. You think it is sine, so it's good enough to tell me why it cannot be cosine. Let's investigate this like one point at a time. It looks like this passes through the origin. So that means when the input is 0, that function is 0. What's the cosine of 0? No. Cosine. If I start at 1, 0 and rotate by an angle of 0, then what x coordinate do I land at? 1. Cosine of 0 is 1. So let's use that. So that means when x equals 0, y should be equal to 1 if this were the graph of cosine. At the very least, it cannot be cosine. Let's check that it at least agrees with what we know about sine. This says when x is 0, the output is 0. Is the cosine of 0 0? Is the sine of 0 equal to 0? Look at your unit circle if you got it. How about pi over 2? What's the sine of pi over 2? Cool. Is that agree with this? Pi? Agrees with this? Yeah, I think this is the graph of sine of x. And I think in general it agrees. If I start with an angle of 0, the y value is 0. As the angle goes up, the y value goes up until the y value gets up to 1, and then it starts coming back down, which agrees with that graph, right?
Yeah.
And then it starts being negative after pi. It gets all the way down to -1, and then eventually back to 0. Yeah, that agrees with what that does. I think this is sine of x. Let's see if this agrees with cosine of x. Cosine of 0 is
1.
1. That agrees with the graph, I think.
Yeah.
X equals 0, y equals 1. Cosine of pi over 2 is
0.
cool. I think that agrees with cosine of x. Oh. And there that all that stuff was listed as like that hint. That's okay. All right. So we now have the graphs of sine and cosine. Let's see what we can observe about them. So whenever you have a graph, you can start like asking things based on the graph. What's the maximum value these things achieve?
1.
Right, like how do you read the maximum value from a graph? You ask, what's the biggest y value you see? For cosine of x, because it's the one that's listed first, what inputs result in that maximum output?
2 pi.
2 pi and -2 pi. Are there any other inputs? So by looking at the graph of cosine,
0.
what x values result in a y value of 1? Yeah, 0 seems to do it.
Yeah.
If you continued this graph further, would there be other places where the output value would be 1?
Yeah.
What would some of them be?
4 pi.
4 pi I think would do it, and that agrees with the graph, right? Go all the way around once, that gets you to 2 pi, that's an x value of 1. 4 pi just goes around the circle again. Cool. How about sine? Let's try to find the inputs which give the maximum value for sine. So looking at the graph of sine of x, what x values do you see that result in a y value of 1 on the graph of sine?
-3 pi 2 and pi over 2.
Yeah. So there's the maximum value, so -3 pi over 2. It'll hit there again, like right there. So let's try to figure out more points that do it. What point do you think that'll be? Well, let's see. Looks like 3 pi over 2 does the opposite. It like anti-maximizes. It minimizes. So let's put that there. So 3 pi over 2 minimizes sine. That's kind of like maximizing, but the exact opposite. Let's try just listing them as we go forward. So the max value corresponds to that point on the unit circle. So you get there by going up by a right angle. Or you can get there by going up by a right angle and continuing on until you get back to that right angle. How big an angle is that? Let's see, it's like, it's a multiple of pi over 2. It's a multiple of a right angle. So let's just count forward how many right angles we need. So pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. Can I go forward by another 4 pi over 2 and get back to that point? And the dot 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 is just to emphasize there are infinitely many, and there's some sort of pad on there. Feeling good? All right, let's try the same game for cosine for minimizing. What's the minimum value cosine takes? Nice, and that agrees, like the most negative x value you see on the unit circle is -1. What input values result in that minimum value? I hear a plus or minus pi? And that agrees, that corresponds to those 2 points. Are there any other points that result in that minimum value if we want to keep on graphing? I don't think 2 pi, but I like 3 pi. Let's actually pull up a Desmos graph, right? We can. So let's do. So there's the graph of cosine. I want to know when it is -1. So there's the negative pi and pi, and 3 pi does it. So notice 2 pi is that point that maximizes. So it looks like even inputs, even multiples of pi maximize cosine, odd ones minimize. And that agrees with the unit circle. Odd multiples of pi will put you over here, put you at an x value of -1. Cool, feeling pretty good. Let's ask even or odd functions, even or odd questions. So there's the graph of sine of x. Nope, it asks about cosine first. There's the graph of cosine of x. Even or odd or neither, or both. How do you check for evenness or oddness?
The even reflects over the y.
Even reflects over the y-axis. So, graph of cosine is right there. Does it reflect over the y-axis to give the same graph again? Cool. So is it even or odd?
Even.
It's even. And you know what? Just to do a quick double check, what does it mean to be even? It means that like f of x is the same as f of -x. Well, that's something you can now check by like using a graphing machine. So there's cosine of x graphed right there. There's the graph of cosine of -x. Look like the same graph again? Nice. So I think it is even. The graph of sine is also there. How do you tell if a function is... So you told me how to tell if a function is even. You reflect over the y-axis and see if you get the same graph. If you reflect sine of x over the y-axis, do you get the exact same graph again? No. So it's not even. How do you tell if something's odd?
It reflects over the origin.
See if it reflects over the origin. And reflecting over the origin is something you can physically do in the plane. If you pin down the origin and rotate 180 degrees, does that graph now look like the same graph as we had before? Yeah, cool. So sine of x is odd. And in order to check that, let's see if it satisfies the equation that governs oddness. If you stick a negative in front of the input, does the output become negative? So let's graph, I guess, negative sine of x. There it is. And sine of -x. Those look like the same graph? Awesome. So cosine is even, sine is odd. That means that whenever you're doing like algebra with a bunch of trig functions and you see a negative in front of a cosine, you can ignore that negative sign. Whenever you see a negative in front, inside of a sign, you can pull it out front. That's something worth remembering. That'll let you simplify some things. Another thing you can tell by looking at a graph, intervals of increase and decrease. So, let's go back up here, look at the picture. It says to do sine first. Let's do sine first. So let's start at the origin. Does it look like the function is increasing at the origin? How far to the right can I keep on going while still being increasing?
Pi over 2.
Until pi over 2. So one of the intervals of increase ends at pi over 2. How far to the left can I go from the origin and be decreasing? And be increasing? 0?
You can't. From the origin, and you're increasing.
Is it negative pi over 2?
Yeah, so like I get why you're saying what you're saying, because like if I go left, the y value is going to go down. But like the x value is also going down. So maybe the better way to ask is like,
That is from the origin, not from
I agree that what I said was maybe, how big could I make that purple interval and still have the thing be increasing, is maybe the best way to say it. And negative pi over 2 is the endpoint. So negative pi over 2 to pi over 2, it is increasing. And that means that at pi over 2, it probably starts decreasing. How far after pi over 2 can you keep going and still have it be decreasing?
Pi over 2 is 3 pi over 2.
Are you at 3 pi over 2? People agree? Nice. And that's just like reading from the graph. And I don't know, maybe we'll like see if that agrees. So the first line, the line in purple says if you start at negative pi over 2 and you start going up, the y value goes up because y is sine. Yeah, that agrees. My finger is going upward until I make it to a right angle, and then my finger starts descending again until it makes it to 3 pi over 2. And then it'll start going up again. How long until it'll stop going up? Well, I guess like whatever that angle is, right? Which I think is 5 pi over 2, because there's 2 pi, which is 4 pi over 2, plus another 2, plus another pi over 2. So from 3 pi over 2 to 5 pi over 2, it increases. Then from 5 pi over 2 until, so I'm definitely like beyond the edge of what's graphed on the paper at this point. So 5 pi over 2, and then I continue increasing the angle. The y value goes down. How long until it stops going down? Guess it's like as soon as I get down there. So let's see, that'll be 5 pi over 2, 6 pi over 2, 7 pi over 2? And of course, if I just keep on going, then I'll never actually stop, so. There's some repeating pattern in both directions. And it looks like all of those intervals are length pi, so it's increasing and decreasing a length of pi at a time. Yeah.
Looks like the pattern is just increasing by 2 pi.
Yeah, cool. So from there to there increases by 2 pi?
Yeah. Or,
Yeah.
yeah.
Yeah. If I take this one and I shift it by 2 pi, I'll get the next one.
So it's basically a fuller, like a fuller.
So let's write that down. Consecutive intervals of increase are shifted by 2 pi. So as soon as you find one interval of increase, just keep shifting that right by 2 pi or left by 2 pi, and you'll keep getting more of them. And keep this in mind. This, you can shift by 2 pi and get something to happen. Let's look at the graph of cosine. So starting at 0, well, 0 looks like a turning point already, right? So I think 0 is an endpoint of an interval of increase. How far to the right after x equals 0 can you go and still have cosine be increasing?
X.
Yeah, but what x?
Oh, sorry, pi.
There we go. Yeah. Nope, you're good. All right, that means at pi it must change. How far can you keep going after pi and have it be decreasing? Oh, God damn it. These are all swapped. Right, from 0 to pi, cosine is decreasing. 0 to pi is an interval of decrease. At pi, it starts increasing. How long does it keep increasing?
2 pi.
Till 2 pi. At 2 pi, it starts decreasing again. And maybe just by thinking about the same intuition, how long do you think until it stops decreasing? Here at 3 pi. And all right, that agrees. If I shift this over by 2 pi, instead of having it be 0 to pi, it'll be 2 pi to 3 pi. It then increases from 3 pi to 4 pi. And this pattern continues forever in both directions. Feeling good? Nice. So, think about that observation you just made. There's some like repetition of what happens in terms of intervals of increase and decrease. It looks like it repeats every 2 pi. That sort of behavior is called periodicity. So here's a definition of what it means to be periodic. A function is called periodic if there's a non-zero number, p. In fact, you may as well make it positive. So that f of x plus p is the same as f of x. The smallest positive number p that satisfies that is called the period of this function. So, let's try to determine the period of cosine. Period of sine. No, we're going to do cosine because that's what the paragraph sets up. Any intuition just based on what we see already?
We're doing sine or
Let's do cosine.
maybe pi or something.
Cool. It'll have something. It should have something to do with pi. Well, let's see. There's the graph of cosine of x. So as you said, it'll have something to do with pi. So let's take p to be something times pi. Let's let that something change. I'll start at 0.1 and let it increase. There's the graph of cosine of x plus p. It looks like a shift of cosine, but you knew it would be. Let's see what happens as we start increasing k. That look pretty close to being on top. So what's the period? Two times pi. So, and that now explains these shifts of 2 pi. It was increasing on one interval, and this thing has period 2 pi. If you shift by 2 pi, you'll get another interval of increase. So it sure looks like the period of cosine is 2 pi. And you know what, let's do sine of x too. What do you think the period of sine of x should be? I hear a motivation for 2 pi. Sine and cosine look really similar to each other, don't they? So let's see. I think 2 pi seems like a reasonable bet. Let's check it by graphing. So I guess I want to replace that cosine with a sine. I want to replace this cosine with a sine. Oh yeah, that looks like it's pretty dead on. Period of sine is also 2 pi. All right, so we wrote off lots of things from the graph of sine and cosine. Let's think about this fact that sine and cosine look really similar to each other. In fact, it looks like if you just like took cosine and shifted it over a little bit, you'd get the graph of sine of x. Yeah. So let's try to figure that out. let's figure out how far you would need to shift cosine of x to get the graph of sine of x. And I think I'm going to try to shift right by some amount to do this. No, I want to do the opposite. Does cosine look like it's given by shifting sine? So there's sine of x. It looks like there are 2 points where the graphs look the same. So how far to the left do you need to shift sine of x to get cosine of x by looking at those points? Those points seem to suggest. Let's see if this just holds for other points. There's a point at pi 0, there's pi over 2, 0. Do those 2 points differ by shifting left by pi over 2? Yep. And let's explicitly check one more pair. Those two shift by pi over 2? Nice. So, how do you shift a graph left by pi over 2? What do you do to the function? Yeah. So, that tells you something about the relationship between sine and cosine. Cosine is the same as sine, but shifted by pi over 2. Cosine of x is equal to sine of x plus pi over 2. And you know what? Let's again just check this graphically. Let's sketch the graph of cosine of x, not the cosine of 9x. Sine of x plus pi over 2. Yeah, nice. They agree. So there's a relationship between them. So that'll be important. That means that as soon as you've proven something about sine, you've also proven something about cosine. So if you like, there are like two relationships we now have between sine and cosine. Sine squared plus cosine squared is always 1. And they also differ by a horizontal shift of pi over 2. Nice. All right. Next thing on the list is the word amplitude. So, sine and cosine have a period, which is how far to the left or right do you need to shift to get the exact same graph back. And if you like, that's like, how far is it between those peaks of those, how far is it between those local maxima? That's the same as the period. Well, there's one other obvious thing you can now ask. How big is the amplitude? How high up are these peaks and valleys? And I think it better be 1. So let's write down a definition that makes it be 1. And that'll be the definition of the amplitude of any periodic function. The amplitude of a periodic function is 1/2 the difference between the maximum value and the minimum value. And the reason for that 1/2 is just to avoid the amplitude of sine and cosine being 2. Because I would rather the amplitude be 1, so I don't want to measure that whole distance, I just want to measure half of it. Feel good right now? All right. So amplitude of cosine is 1, amplitude of sine is 1, and maybe we'll just check. What's the maximum value of sine? What's the minimum value of sine? And then I want 1/2 of that. Is that equal to 1? Awesome. All right, so a general sinusoidal function is a function that looks like this. Something that's on shift and stretch of a sine function or a cosine function. Let's talk about how to graph them, and in particular, how to extract their period and amplitude. So, that doesn't look like a hard function to graph, does it? That looks like a function you already know how the graph should look. It's just a matter of remembering like what order you're supposed to deal with these ingredients in. So, I don't know, let's start with the graph of sine of x. I know what that looks like. And I don't know, I've just labeled enough things. The period's 2 pi, it goes through 0, 0, the amplitude is 1. What things am I supposed to deal with first in this graph if I want to graph that thing? Yeah,
Either way, interesting.
the y-intercept.
Oh, because it's possible, right?
Ooh, that's not the first thing I want to deal with.
Oh,
You deal with this first. So you deal with the vertical stretch first, then you do the shifts, then you do the horizontal compression. So let's deal with that 2 first. What does that -2 do to the graph? Stretches it and flips it. So let's flip over, how am I doing for time? Y-axis and double the y values. All right. So 0, 0 will still be at 0, 0. This point 0 pi will still be 0 pi. But now the peaks will become valleys and they'll be twice as deep as they were tall before. So let's see what that does to things. What's the amplitude now? Amplitude is now 2. That distance is 2. And it's like pointing down now, but the amplitude is always positive. If you like, the minimum and the maximum have swapped, but that's okay. And what's the period? Still 2 pi. I haven't done anything horizontal, so period should still be the same. And it still goes to the point 0, 0. All right, next thing, let's deal with those two things. So this right now is the graph of -2 sine x. What will those two things do to the graph?
Shift the rate to sine of the.
Yeah, same what you said earlier. Cool. So let's take these, go right 2 up 3. Right 2 up 3. So this point that used to be at 0, 0 is now right 2 up 3. And now I just want to take that whole graph above and shift it accordingly. Oh, yeah, sorry about that. So it starts going down, so we'll start by going down. It looks like I need to go down a total distance of 2. All right, and maybe I'll draw like the middle line there as well. So let's now address the same things. What is the amplitude of this function? Still 2? I've just taken the whole thing and shifted it up. The amplitude doesn't care if you shift it up. Amplitude is 2. What's the period? Still 2 pi. I haven't done anything that changes the period. All right, cool. What's the last thing I need to deal with? The 2/3. So the last thing I need to deal with is I need to finally get the graph of, well, I guess I have a space right here. So this will be the graph of -2 sine of -2/3 x minus 2 plus 3. And this is the last thing to be dealt with. What does that do to the graph?
Is that the same as the slope?
It's not like a straight line, so there's not like this has something to do with slope. There's no straight line to walk with.
Does the opposite opposite of what you think it would, so it would be dividing each x value by 2/3.
Nice, let's write that down. We will divide all x values by -2/3. So all the new x values will be the old x values divided by -2/3, and now let's simplify that. Same as multiplying by -3/2. So all the old x values will get multiplied by -2/3. So I guess that means there will be like a flip over the x-axis, a flip over the y-axis, and there will be a scaling. So let's do that. This is the only point that I've labeled right now. Where does 2, go when you do this? So the x value will change. So it'll become -3/2 times 2, so -3. And the y value stays the same. We're not doing anything to y values. And now instead of this thing going down from there, it'll go down in the other direction. All right, so it looks like the average line is still at 3. Let's determine the period and amplitude now. What's the amplitude? Still 2. You've done something horizontally. The amplitude didn't change. What's the period? Is it still 2 pi? So this is like the distance between 2 adjacent peaks. So let's see. The distance between 2 adjacent peaks used to be 2 pi. But now what have we done? We've flipped it over the y-axis, so it goes the other direction. And then we've scaled it up by 3/2. So I think it's now 3 pi. Because it should be 2 pi times 3/2. And you know what? Let's go ahead and just check this. Let's graph this thing. And also read off the period and amplitude from that graph. -2 sine of -3/2 x -2 plus 3. So there's the graph of this thing. The period is the difference between consecutive peaks. So the period is the difference between those two things. I guess to compute that, let's compute it and see if it agrees with 3 pi. So 3.903 minus 2.86, 0.286, right? That gives me some number. Did I copy this down right? No, I didn't. This should be a 2/3, right? Now did I copy it down right? All right, well, wish I'd noticed that sooner. All right. 8.781. And -6.44. 0.644. That gives me a number. Remember that? That look like about the same number? Nice. So the period is in fact that 3 pi. In general, you can always read off the period and amplitude of a sinusoidal function by just seeing how it's written down. As you notice, those two numbers don't affect the period and don't affect the amplitude. Horizontal shift doesn't do anything to period and amplitude. If you want the amplitude, Well, that -2 is the only thing that did anything to the amplitude, right? Amplitude used to be 1, but then you doubled everything and you flipped. The flip doesn't matter. But you doubled all the y values, so the period got doubled. Oh no, I wrote that in the wrong place. The amplitude of any periodic, of a sinusoidal function is just the absolute value of whatever it is that's written next to that sine or cosine. The period, well, the period of the original function was 2 pi. And then that 2/3 resulted in multiplying by 3/2, because that's the same as dividing by 2/3. Hard to read. So the period of any periodic function is 2 pi divided by, God damn it, Chris. The absolute value of that parameter, omega. Yeah,
Is that the same W for angular speed?
it's very much related. So let's notice what you said earlier. You said like this is like a slope of a line. So that's like how quickly the thing you're plugging into the trig function is changing. Ooh, the thing you plug into a trig function is an angle. So that omega is acting a lot like a rate of change of an angle. So it's an awful lot like an angular speed. Yeah, you should think of this as being like, you have an angle that's shifted down by a total of 2 radians, but then it's spinning -2/3 radians per unit time. And then you're taking a trig function of it. Feel pretty good? Nice. All right, so you can now identify the period and amplitude of any sinusoidal function. This idea will be closely related to the open-ended homework for the day. It'll be studying an explicit periodic function. You'll compute its period and amplitude and use that to put it in this form. Nice. All right. Final thing. So we've studied sine, cosine, sine and cosine in depth now today. But tangent, secant, cosecant, and cotangent are all also important functions, less important. Let's try to figure out which of these is which. So each of these are the graphs of either sine, cosine, secant, or tangent, cotangent, secant, or cosecant. Which one's which? Maybe I'll label them. Let's make a multiple choice. And like, there are ideas down here to explore. So what's like something you know about one of those functions? Yeah.
Tangent of y over x, so x is going to be undefined at.
Cool. So this thing will be undefined, and in fact it'll have a vertical asymptote when cosine of x equals 0. When is cosine of x equal to 0? That's one of them. Pi over 2 is one of them. Where else? Anywhere else? Or maybe that's just enough to walk with. Nice. And also minus 3 pi over 2, but if we just start listing all of them, we'll never stop. There are infinitely many places. It's a periodic function. So, tangent has a vertical asymptote at those inputs. Which of these graphs given has a vertical asymptote at those inputs? Let's go through one at a time. Does A have a vertical asymptote at pi over 2? 3 pi over 2? Negative pi over 2? Negative 3 pi over 2? Cool. Let's move to the next one. Does B have a vertical asymptote at 3 pi over 2? No. So tangent can't be B. Might be A. How about C? Vertical asymptote at pi over 2, vertical asymptote at 3 pi over 2. Might be C. Could it be D? All right. So it's not enough information yet. What else do we know about tangent? So let's go through the questions. Where should the vertical asymptotes be? We listed those. What options does that eliminate? We eliminated some options. What's the y-intercept of the graph of tangent of x? So I guess that means plug in x equals 0. So what's the tangent of 0?
0.
All right. So the y-intercept should be at 0, 0. So let's take a look. A and C are the only options left. What's the y-intercept of A?
0.
What's the y-intercept of C? So which one's the graph of tangent? Neato. And I bet if we can figure out which one has these vertical asymptotes, we'll also figure out which one is C. So let's go through the list. Secant looks like that. Where does this have a vertical asymptote? Same spots as tangent. Vertical asymptote means you divide by 0. So let's look for that. This has a vertical asymptote when cosine of x equals 0. Oh, cool. That's like the exact same thing as is written above. So, which one of these must be the graph of secant? And I think in the interest of time, let's spoil it a little bit. This graph B is the graph of cotangent x. Maybe that's not so surprising. Tangent is y over x, cotangent is x over y. Those two things just seem like they're related. So, graph of cotangent should look related to the graph of tangent. Instead of sine over cosine, it's cosine over sine. The graph of cosecant, well, secant is 1 over cosine, cosecant is 1 over sine. Sine and cosine are super closely related. They're just shifts of each other. So these two should be shifts of each other. Feel pretty okay? Let's try to say a few words about period based on these. Because I think we have enough time. We got 2 minutes. So by looking at the graph of tangent, what would you say the period of tangent is? I hear a pi? Do I hear a second for pi? Yeah, and let's check. So there are two things that it means to be the period. If you shift by pi, then you should get the same graph. Looks like the same graph. Oh, I should close that parentheses. I already did, okay. It should also mean that if you shift by some amount that's less than pi, you don't get the same graph. So let's see, pi is 3.1-ish. If I take a number that's less than pi, do I get the same graph as tangent? Doesn't look like. So I think the period is exactly pi. What does it look like the period of secant should be? So I guess like I want to shift this to get to that point. How far do you have to shift to do that? 2 pi. So what's the period? Nice. And that makes sense because secant is just 1 over cosine. So that like flips all the y values or it takes the reciprocal of them, but it doesn't do anything horizontally. The period should be the same. Does it look like there's any relationship between tangent and cotangent? Those look like similar in any way? They're just flipped. I think they're more than just flipped. But let's get a cert, so. So there's cotangent of x. If you just flip tangent over the x-axis, you'll get the graph of negative tangent of x. Does that look like the same as cotangent? Not quite. Looks like I need some horizontal shifting too. Maybe think about what that horizontal shift should be. Cool. All right. So here is what I would like you to do in the next 23 hours. Today's Thursday, so the homework all comes due tomorrow night. If you haven't already looked at that homework, that was a mistake. You should have done that, all the question pointer was assigned that. But make sure you've taken a look at all the homework that's due tomorrow. If you have any questions about those, even like I have no idea how to get started on it is a fine thing to ask. Bring those questions at the start of class tomorrow. Oh, and I also gave out the review for the midterm. Take a look at that too. The midterm is on Wednesday. You do. Ooh, and if you do the midterm through the testing center, I'll make sure to set that up. Your desk looks clear. I think you're good.
Right, well,